Okay, so hello everyone, good morning. Okay, so hello everyone, good morning. Okay, good morning everyone. So, in my previous lecture, we talk about the nomenclatures of amides. Okay, I think acetamide, formamide. Okay, and and dimethyl ethanamide and all these things. Okay, let's remind once again. Okay, so as like here CH3 C double bond O, then NH2. It's a acetamide. ACETAMIDE. Acetamide or ethanamide or IUPAC name ethanamide. Okay. ETHANAMIDE. Ethanamide. Okay. Next, another. If here like a H C double bond O NH2. Okay. It is a formamide. 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 Okay. It is also called as methanamide. 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 Okay. Next. Okay. Remember why I call it as a aceta, because two carbons, so aceta. One carbon, that's why it is called forma. Okay. If there will be a three carbon as like a CH3, CH2, then C double bond O and H2. Its name is propanamide. Okay. PROPANAMIDE, propanamide. Okay, or propionamide. Okay, it's okay. Okay, both are collectively called as same. Okay, but here these are about the primary amides. Okay, primary amides. Okay, primary amides. But here also a secondary amides are available. Secondary amides. Secondary amides. Which are the secondary amides? Listen carefully. Okay, here you say CH3 C double bond O NH2. Okay, its name is acetamide, you know very well. Okay, but here two hydrogen. Okay, one hydrogen here. Okay, this NH2, one hydrogen atom is replaced by one alkyl group. Okay, so I am replacing this hydrogen. One hydrogen is replaced. Okay, and adding a one alkyl group. Okay, so this methyl group, listen carefully, this methyl group is attached to this nitrogen. That's why we call it as a N-methyl. N-methyl. N-methyl and 1, 2, 2 carbon. So N-methyl, what? Two carbons, and that amide is called as acetamide, N-methyl acetamide. ACETAMIDE, and methyl acetamide. Okay, if there will be a HC double bond O, then NH, then CH3. Okay, here is also same. Okay, to this nitrogen the methyl group attached. Okay, see n methyl, and the remaining name is same, acetamide. Okay, so I'm making it in the red circle. Okay, this is nothing but the acetamide. Okay, okay, so listen, here the methyl group is attached to this nitrogen, so here is also same, we call it as a n methyl. Okay, n methyl, methyl, and then here how many carbons? Only one carbon, not a two, as like above. In the above example, here is a two carbon, one and two, so it is called as acetamide. Here is only one carbon. Okay, so it is a formamide. Okay, n methyl formamide, for, excuse me, formamide, and methyl formamide. Okay, next, listen carefully. This methyl group is attached to nitrogen, that's why we call it as a n methyl. Okay, n for nitrogen. Okay, not a n for normal. Okay, here's a capital N. Okay, capital N means for nitrogen. Okay, if there will be a small n, अगर यहाँ पे small n होता तो आप बोल सकते कि वो स्टेट चेन के लिए यूज किया गया है, बट यहाँ पे कैपिटल n है, तो कैपिटल N is for nitrogen. Okay, n methyl formamide. Okay, next, here I am taking the another example. Okay, no need to tell here that this species is called for the formamide. Okay, next, another example. You try to give its name. Okay, CH3 C double bond O, then NH, then C2H5. Okay, try to give its name. Okay, try by yourself. Okay, okay, looking for the chat sections. Okay, tell me. Okay, mm, it's late, I think. uh, so it is ethyl group which is attached to this nitrogen, so its name is n ethyl, n ethyl, and then n ethyl, and then it's a acetamide, n ethyl acetamide, acetamide, acetamide. Okay, next, if there will be a CH3 CH2 C double bond O NH, then here C2H5. Okay, its name will be, try to give its name. Okay, so to this nitrogen the ethyl group is attached. Okay, so its name will be ethyl, n ethyl, then how many carbons are there? Look it out. Okay, one, two, three, three carbons. Okay, three carbons. Okay, excuse me, up to this three carbons. Okay, and here this species. Okay, to which you call it as a one, two, three carbons means propanamide. Okay, three carbon means propanamide, and ethyl propanamide, PROPANAMIDE, propanamide. Okay, so I think its nomenclature is easy. Okay, not that much of difficult. Okay, Janvi replies there. Okay, Hansika also replying. Okay, so easy. Next, talk about the tertiary amines. Okay, these are the secondary. Next, talk about the tertiary amines. Okay, tertiary amides. AMIDES. Tertiary amides. Okay, 3 degree means tertiary. You know very well. Okay, primary we can represent it as a 1 degree, secondary for 2 degree, and tertiary for 3 degree. Tertiary amides. Okay, next, here listen. You know, as like a CH3 C double bond O, C double bond O, CH3 C double bond O, and here NH2, acetamide. Okay, but in this case, in the primary amine we are not going to replace these hydrogens. Okay, but in the secondary amines we are replacing one hydrogen, but in these tertiary amines we are replacing both of these two hydrogens. Okay, so I'm going to remove these two hydrogens. Okay, and adding there two alkyl groups. Okay, one and second. Okay, two alkyl groups. So its name will be, okay, try to give its name. Okay, listen. So to this nitrogen, two methyl groups are attached. How many methyl groups? Two methyl groups are attached. Okay, so its name will be N comma N. Okay, how many methyl? Dimethyl. N dimethyl. N dimethyl, and two carbons. Okay, look it out, two carbons. Okay, and including this nitrogen. Okay, so its name is acetamide. Okay, two carbon acetamide. ACETAMIDE, and dimethyl acetamide. Okay, I think it's easy. Okay, see, listen carefully once again. These two methyl groups are attached to, see, listen, and these two methyls are attached to the nitrogen. So one N for one first methyl, second N for second methyl, and so how many methyl? Dimethyl. Okay, two methyl, dimethyl, and this red in color which I highlighted here is acetamide. Acetamide. That's why its name will be NN dimethyl acetamide. Easy. Next. Okay, so this is the example of tertiary amide. Okay, one more example I'm taking here. HC double bond O, then N, then here CH3, and here C2H5. Okay, try to give its name. Okay, so listen carefully. To this nitrogen, one methyl group and another ethyl group. Okay, so for this you have to give the name for both. Okay, and first methyl come or ethyl come, the M for methyl or E for ethyl. So E for ethyl, so ethyl N ethyl, and another N, and what you write? Methyl, N-ethyl and methyl. Then how many carbons here? Only one carbon, this carbon. Okay, only one carbon. Okay, so to which you call formamide, only one carbon and amide. Okay, formamide, Formamide, formamide. Okay, so listen, this formamide is for these structures. Okay, and this methyl, one N methyl, so N methyl. Okay, and N ethyl. As the E come first, so that's why we're writing here ethyl, and then M, so methyl. So N methyl formamide. Okay, next, try this example by yourself. CH3, then C double bond O, then N, then here is methyl, and here ethyl, C2H5. Okay, C2H5. Okay, try this by yourself. Okay, try this by yourself. Okay, to this nitrogen, methyl group is attached and ethyl group is attached, similar in the above example. Okay, and here this is your amide. Okay, so what will be its name? Okay, I think you can able to give its name. Okay, so I'm writing N ethyl, then N methyl, N ethyl, N methyl, then acetamide, Acetamide. Okay, I think that was easy. Okay, so this N ethyl, N ethyl, so N methyl, N methyl, and this red in color, which represents you the acetamide. Okay, which represents you the acetamide. Okay, easy. So these are the primary amide, secondary amide, and tertiary amides. Okay, so here the nomenclature of amide are completed. Okay, now let's talk about the another nomenclature. It is nothing but the acid anhydride. Let's talk about the acid anhydride. Acid anhydride. Okay, so few things about the acid anhydride I want to share with you. Okay, acid anhydride are the species. Okay, for example, let me introduce you. C as like acetic acid, you know very well. CH3 COOH. Okay, acetic acid. Okay, how acidic anhydrides are formed. Okay, I'm going to represent you. CH3, another molecule, C double bond O, C double bond O, and O and H. So how many moles of this acetic acid? Two acetic acid. Okay, so uh, so dehydration takes place. Okay, at a particular temperature, the removal of water takes place. Okay, so see, listen here, removing one somewhere else from a OH and somewhere else from the H, so H2O is removed. Okay, see the H2O. Okay, HOH. Okay, so this bond, the carbon having this bond is directly attached to any one of these oxygen. Okay, this oxygen. Okay, so your structure will be like CH3. Okay, this CH3. Okay, then C double bond O, C double bond O. Okay, then O, this O. Okay, this oxygen. Okay, I'm highlighting this oxygen. Okay, this oxygen, this oxygen. Okay, this red in color oxygen. Okay, this oxygen. Okay, this oxygen, and which is attached to C double bond O again. Okay, C double bond O, then here CH3. Okay, here CH3. Okay, so I can also write, this is nothing but these are the acetic acid, excuse me, acetic ACE acetic acid. Okay, and these are the anhydride which is forms from the acetic acid, so that's why we name it as a acetic anhydride. Acetic anhydride. Acetic anhydride. Okay, next, so one more thing here, listen, these anhydrides are made up from these acids. Okay, from where the water molecule is removed. Okay, so water molecule is removed from this acidic acid. How many moles here? 2 moles. Okay, here I'm writing 2 moles. Okay, 2 moles. Okay, 2 moles are very much necessary. Okay, so 2 moles of acetic acid, the removal of water molecule from it, it forms acetic anhydride. So as it forms from the acetic acid, that's why we call it as a acetic anhydride. It's a propionic acid, so it's a propionic anhydride. It's a formic acid, so we call it anhydride. Okay, it depends upon uh, that species where the acid we used in the previous step. Okay, so the name of this anhydride is depends upon the acid which from which it forms. Okay, So this is the acetic anhydride. Sometimes we also call it its structure as like a or or you can also draw its structure as like a CH3 na CH3, then C double bond O, C double bond O, then O, then what? O, okay, red in color your O, okay, O, then what? C double bond O, okay, C CH3 C double bond O O, CH3 C double bond O O, then C double bond O, then C double bond O, then CH3, then CH3. Okay, so you can also draw this structure or you can also draw this structure. Both are exactly the same. Okay, acetic anhydride. Okay, so one more thing about I want to share with you. These anhydride forms are much more reactive than these acetic acids. Okay, than the corresponding acids. Okay, so listen. Wherever necessary, somewhere else you are putting the acetic acid reaction. Okay, so you are putting some acetic acid, the reaction goes normally. Okay, but you are putting the acetic anhydride instead of acetic acid. Okay, the reaction goes vigorously. Okay, so because the acetic anhydride is much more reactive, much more reactive than the corresponding acetic acids. Okay. So acetic anhydride is much more, or any anhydride, okay, any anhydride is much more reactive than its corresponding acids. Okay, remember these words. Okay, acid anhydride forms of any substances are much more reactive than its hydrous form. Okay, to which you call acids form. Okay. So let's start its nomenclature. So this is your anhydride, okay, about which we are going to discuss in this nomenclature. Okay, so acetic anhydride. Okay, uh, let's take one another examples and try to give its name. Okay, as like here if you write H C double bond O, then O, then C double bond O, then H. What will be its name? Or the structure you can also draw like H C double bond O, then O, then C double bond O, then H. Okay, so these and these structures are exactly the same. I also write here or, so listen to this. Okay, this structure or this structure. Okay, so what will be its name? So I think these are comes from these structures. Okay, as like CH3, sorry, excuse me, I think this comes from like these structures HC double bond O, then here OH, then here HC double bond O, then one more OH. So H2 is removed. Okay, so listen carefully. H2 is removed, H, and here OH. These are going to removed. Okay, and this carbon is attached to this oxygen. Okay, and it forms this kind of structure. So these acids are formic acids. Okay, two formic acids. So its name will be formic anhydride. Okay, formic anhydride, because it will made up from the formic acids. So that's why we call it as a formic anhydride. Okay, so I can write its name here, formic anhydride. Formic anhydride. Okay, next another example you can take here. Another example, CH3 CH2, then C double bond O, then O, then C double bond O, then CH2, then CH3. What will be its name? Okay, of course it is anhydride, ANHYDRIDE. But this anhydride is made up from which acid particularly? Okay, I think you already guessed. Okay, So 1, 2, and here 3. 3 carbons means propane. So propanoic anhydride. Propanoic, Pro, propanoic, propanoic anhydride. Okay. So propanoic anhydride. Okay. Excuse me. Propanoic. Okay. Propanoic anhydride. Okay, easy. So there is nothing much more to learn about these anhydrides, but listen, the particularly this acetic anhydride is very 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 important. Okay, so I'm telling you this, excuse me, this acetic anhydride is very 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 important. Okay, so just learn this structure: CH3 C double bond O, O C double bond O, CH3, acetic anhydride. In many reactions, the acetic anhydride is used. Okay, and going to prepare. So you must have to remember this acetic anhydride. Okay, particularly these anhydride. I'm not going to talk about these anhydrides as like a formic anhydride, propanoic anhydride, but this particularly acetic anhydride is very much famous. Okay, used in various reactions. Okay, so these are about the anhydride. And one more here, uh, let's discuss about the new topic. It is nothing but the acyl chloride. Acyl, ACYL, acyl chloride. Okay, acyl chloride. Okay, as you discussed there, the acid anhydride are the derivatives of acids, of course, because they are made up from the acids. Okay, that's why we call it as a acid anhydrides. Okay, similarly, as like this is your particularly acid, and here this is a acid. Okay, you know carboxylic acid, any carboxylic acid. So here the negative part, this is a OH. So OH is replaced. If you replace this OH, okay, if you replace or remove this OH group, okay, removed this OH group and going to attach their chlorine. Okay, so this is nothing but the chloride, particularly to which you call acyl chloride. Okay, this is nothing but the acyl acyl chloride. Okay, so this is your acyl chlorides. So these are also the derivatives of acids. These are also the derivatives of acids. Okay, carboxylic acids. Okay, these are the derivatives of carboxylic carboxylic acids. Okay, derivatives of carboxylic acids. And one more thing, here you can also say acid anhydrides also the derivatives derivatives of carboxylic acids. Carboxylic, or you say organic carboxylic acids. Okay, okay. So see, listen here, the OH, the negative part OH is replaced. Okay, this OH is replaced. OH is replaced by chlorine. Replaced by, excuse me, replaced by chlorine. Okay, so that's why we call it as a acyl chloride. Okay, so let us take some examples here. Examples. Okay, so HC double bond OCl. Okay, so this is also chloride. Okay, of course. So as like this structure, chloride. Okay, chloride, CHLORIDE, chloride. But particularly this is formed from the formic acid. So formyl chloride, formyl, FORMIL, formyl chloride, or formic chloride. Okay, formyl chloride. Okay. Next, another example, if you take CH3 C double bond O. Here I'm writing C double bond O. Then Cl. Okay, C and here L. Okay, so its name will be, excuse me, C L C L. So its name will be, chloride. Of course, chlorine is there, so chloride. So listen here, which chloride? It is nothing but the two carbon. So acetyl chloride, ACETYL, acetyl chloride. Hansika says use black pen. Okay, I use black pen there. Okay, of course. I think Hansika can't able to see. Okay, these are the PPT notes. Okay. Okay. So another example here I'm taking. If there will be a CH3 C double bond, um, C double bond, or you say CH2, excuse me, CH2 C double bond O Cl. Okay, so its name will be, so of course it will be a chloride, CH, excuse me. Of course it will be a chlorine attached, so chloride here, CHLORIDE, but as like acetyl chloride, so propyl chloride, PROPYL, propyl chloride. Okay, then butyl chloride, as like acetyl chloride here, formyl chloride, acetyl chloride, propyl chloride, butyl chloride. Okay, so similar cases. Okay, uh, as like benzoyl fluoride. Okay, they are taking in aromatic compound CH, benzene ring, then C double bond OCl. So its name is benzoyl fluoride, BENZOYL, benzoyl fluoride. Okay, the benzoyl fluoride is very much famous for preparation of brown sugar and other narcotics drugs. Okay, so these benzoyl chlorides are nowadays banned. Okay, why this particular chemical is on ban? Okay, why? Because this benzoyl chloride is used for preparation of brown sugar and all these things. Okay, I'm talking about the drug brown sugar. Okay, so that's why these benzoyl chloride are not easily available in the laboratories. And yes, of course, it is a highly reactive substance. Okay, so as like anhydrides, these acyl chlorides are also highly reactive than normal acids. Okay, so anhydrides are also reactive, much more reactive. Acyl chlorides are also much more reactive than particular carboxylic acids. Okay, that particular organic acids. Okay, so these are about the nomenclatures of acyl chlorides. Okay, then one more example here I covered, as like a sulfonic acid. Okay, so acetyl sulfonic acid, benzoyl sulfonic acid here I'm taking. Okay, taking on the another slide here. Sulfonic acid, SULPHONIC, sulfonic acid or sulfonic acids. Okay, so particularly sulfonyl group is nothing but the S double bond O double bond O, like OH. This is nothing but the sulfonic acid. Okay, as like you say carboxylic acid, and here will be certain attachment. Okay, and this is the functional group particularly. Okay, so for example, okay, here example, if you take, so benzene. Okay, why I'm taking directly the aromatic compound? Because this acid is very famous. Okay, this sulfonic acid is very much famous. So benzene and S double bond O, S double bond O, OH. Okay, its name is benzene sulfonic acid, benzene sulfonic. Benzene sulfonic acid. Okay, very famous. Benzene sulfonic acid. Okay, benzene sulfonic acid. Okay, it is too much famous. Benzene sulfonic acid. Okay, then acetyl sulfonic acid you can also use here. Okay, you know, if you use two carbon, okay, acetyl sulfonic acid. Okay, another example, if you take here CH3 CH2 S double bond O double bond O O H. Okay, not much more famous. So it is nothing but the acetyl sulfonic acid. Acetyl sulfonic sulfonic acid. Okay, but out of which this benzyl sulfonic acid is much more famous. Okay, this benzene sulfonic acid is very important. Okay, so very important. Okay, many times the benzene sulfonic acid is only used, okay, in many reactions. Okay, these acetyl sulfonic acid and all these things, okay, not much more famous in the many reactions. Okay, but if you talk about the names of sulfonic acid, benzene sulfonic acid is very much useful. Okay, nice. Next, let's talk about the nomenclature of alkenes, alkynes, alkanes. Alkanes are does not having any functional group. These are the straight chain alkanes. Okay. If you talk about the alkenes, okay. Um, okay. If you talk about the alkenes, alkenes are also called as olefins. Okay, alkenes are also called as olefins. OLEFINS. Alkenes are also called as olefins. Okay. Next, why we are talking about the alkenes, not starting from alkanes. Alkane does not having any. It's a straight chain. Okay. Then alkene having only once, at least once. Okay, at least. I already discussed about this topic in the regular classes. Okay, it having at least once carbon carbon double bond. Okay, at least once carbon carbon double bond. Okay, to which we call alkenes. Okay, and it is having a if if only once, if once, if one carbon carbon double bond, then then follows the formula, follows the formula, which formula you know very well. Okay, it is nothing but the CnH2n. Okay, where in this formula n is equals to 2, 3, 4, 5 and so on. Okay, but not starting from 1. Okay, remember there is no 1. Okay, not 1, starting from 2, 3. Why? Because I carbon carbon double bond required. Okay, if there will be only one carbon, then how it will be form a double bonds with another carbon. Okay, that's why I starting from the 2, 3, 4, not from 1. Okay, nice, remember this. Okay, and many times I told you this formula in the class, so I think each and every student already knows about the alkenes. Okay, but if we talk about the priority to the particular group, okay, coming to the topic CH3, CH2, then C, H double bond C, um, H, then CH3, and here will be removing one hydrogen. and going to attach here one halogen as like a one halogen. Okay, what will be its name? Okay, so in this case you always select long carbon chain, you know very well. Okay, whenever you are going to give the nomenclature to this compound, I am talking about IUPAC especially. IUPAC are a lot of time used here. So starting from this you are going to give the numbering to this. Okay, so 1 2 and the second carbon there is a substitution, but here the double bond comes first from the right hand side, so numbering will start from this is the carbon number 1, carbon number 2, carbon number 3, carbon number 4, then carbon number 5. Okay, carbon number 5. Why? Because we are going to give the priority to this carbon carbon double bond. Okay, going to give this priority to this carbon carbon. Okay, carbon carbon double bonds. Okay, so that's why we are starting the numbering from the right hand side. Okay, so eliminating this chlorine. Okay, on the carbon number 4 there is a chlorine, so 4 chloro, 4 chloro, then 1 2 3 4 5 5 carbon. So okay, 5 carbon butane, so double bond, so butene, but double bond is on 2, so excuse me, chloro, then BUT, then ENE, butene. The spelling is BUTENE, but before this ENE, where is the ENE? Means carbon carbon double bond on the carbon number 2. So but 2ene. So 4 chloro but 2ene. Okay. Similarly, taking another example, CH3 CH, here Br, okay, and here the double bond, and here CH2. Okay, so where you start the numbering? Okay, select a long carbon chain, select a long carbon chain, and the numbering start from left hand side or right hand side? Right hand side, because the double bond comes first. So carbon number 1, carbon number 2, carbon number 3. Many people says, sir, if you are taking from this carbon number 1, 2 and 3, so bromine will be there, na? So no need to worry about the position of bromine. It always comes on the second carbon. It's okay, but the numbering should be given from the right hand side, not a left hand side. Okay, so its name is uh, 2 bromo. Its name is 2 bromo, 2 bromo. Then 1 2 3, so propene, PROPENE. Okay, some students try to object here. Okay, try to take objection on this particular name. Sir, propene, no, not a propene, propene. Okay, but to this students I want to tell you few things. So if you are starting from, if you are going to give here double bond or here double bond, it will always comes first. There is a, if you take a propene, okay, the double bond always on the first carbon. Okay, not a second carbon possible. Okay, that's why no need to write here 1 in. Okay, prop 1 in, no need to write 1 propene or prop 1 in. Okay, 2 bromopropene, that much is sufficient. This name is sufficient. Okay, next, taking another example, CH3 CH2 C H double bond C H, then C, then CH2, then CH3. Okay, so going to remove this and going to attach here substitution. Here well substitution is going to attached from here, okay, chlorine. Okay, so where the numbering should start, okay, 1 2 3, and here 1 2 3, okay, both sides same, but the chlorine come first from here, from right hand side, so that's why we are of course selecting the long carbon chain, okay, but the numbering should start from this side, okay. This is a carbon number 1, this is a carbon number 2, carbon number 3, this is carbon number 4, this is carbon number 5, and this is carbon number 6, okay, carbon number 6, okay. So its name will be 2 chloro, 2 chloro, and how many carbon total? 1 2 3 4 5 6, so hexane, but double bond, so hexene on the third carbon, so hex 3 in, hex ene, hexene, but on the third carbon, so hex 3 in, okay, hex 3 in, so 2 chloro hex 3 in, okay, easy. So taking another example, CH3CH, here CH3, and here single bond CH, double bond CH2. So from where you should start the numbering, okay, selecting the long carbon chain, okay, and numbering should start from which side, from left hand side or from right hand side, okay. So from right hand side, 1 2 3 on the third carbon, okay. So from right hand side, left hand side, 1 2 on the second carbon, okay, but the numbering should be given from the right hand side. Why? Because double bond comes first from there, okay. So this is carbon number 1, okay, carbon number 2, carbon number 3, carbon number 4, okay, carbon number 4, okay. So its name will be 3. On this third carbon, methyl group is attached, so 3 methyl, 3 methyl, and 1 2 3 4, okay. So on the first four carbons means butane, so double bond, so butane, but uh, 1 on the first position butene, okay, so but 1 in, but 1 in, but 1 in, okay. So 3 methyl but 1 in, okay. See the substitution attached to the third, okay. Here the 2 chloro attached to the second, okay. Here third methyl group, so 3 methyl, okay, as like this. Easy now, okay. I think you can able to give the numbering to this particular compounds, okay. It's easy, okay. If there be more than two substitutions, as like CH3 CH2, okay, or you write here C um, CH3, okay, okay. So then CH2, or CH, here C2H5, okay, then CH double bond CH, single bond CH2CH3, okay. If here will be one chlorine, okay, one chlorine, okay. So here this is a double bond, okay. What will be its name, okay. So 1 2 3 carbon, here double bond, here 1 2 3 4 carbon double bond, okay. So numbering start from here, right, from right hand side, okay. So Selecting the long carbon chain. Selecting the long carbon chain, okay, and numbering should start from the right hand side. So carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6, and carbon number 7. Okay, so try to give its name. Okay, so here three substitutions. Okay, total three substitutions, 1, and here 2, and here 3. So it's a chloro. Okay, so C, it's a ethyl, so E, it's a methyl, so M. So first come what? Okay, in alphabet C, then D, then next E, then M. Okay, so first chloro, then ethyl, then methyl. Okay, so first chloro. Okay, so on which position? 4. So 4 chloro, 4 chloro, 4 chloro, 4 chloro, and 5 ethyl, 5 ethyl, ethyl, then 6 methyl, then 6 methyl, methyl, and 1, 2, 3, 4, it's 7, no? 7 means hexane, no double bond, so hexane, so 3, so hex 3 in, okay, H E X X hex 3, then in E N E, okay, hex 3 in E N E. Are you getting here? Okay, hex 3 in. Okay, so looking here, so 4 chloro, so 4 chloro, then 5 ethyl, 5 ethyl, then 6 methyl, okay, 6 methyl, okay, C, then D, then E, then M, okay, and this is a parent chain, and this is a long carbon chain means parent chain, so this is the hex 3 in, okay, easy. So you can take much more example by yourself. I will take it tomorrow. um, we will take about the nomenclatures, alkynes, okay, about alkynes, not now, tomorrow, okay. So okay, I'm here now, stop, okay, thank you, bye bye, and take care, okay, signing out, thank you.